Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. Today we're working on a Ptac unit, and let's see what's going on. Thank you to everyone tuning into Jumperman Tech. So this is a Ptac unit that resides in the wall. We have cooling via refrigerant, and above here we actually have a copper coil, which is how they get their heat. So if you see these copper lines here, it's connected to a boiler downstairs, and there really should be an actuator, but there is none installed, so just runaway heat. But the complaint here is that we have no cooling. So let's see what's going on. So here is the wiring diagram, and this is the only bit of useful information that we can have, because if you search up this unit online, it's made by Evergreen, you can't find anything. And it's not too much to go by, so start by putting the system on. I hear the compressor started. Indoor fan, we got air movement. So we're gonna follow the diagram. I know this is the compressor. Usually runs at about like 3.8 amps, 4.3, 4.4. Okay, compressor is running. We know our indoor fan is running, which is right here. This is the motor right here. So we're also going to want to check temperatures. I feel a little bit of cool air. We're going to want to make sure that condenser fan motor is running as well. So I'm gonna look at our diagram. It's the outdoor fan coming out the board terminal. It's a black wire, and then the other one is white. So it's this is the wire for the outdoor fan motor. That compressor is getting really loud. Our amps just keep rising. It's about 6 amps now. That's really not good. So we do got amps on this fan motor now. It's 0.5. So we know it's pulling something. It's super loud. That compressor really not sounding well. This side should always have voltage for the fan motor, about 120, and I know this white wire is the other side of it, 120. So we got our voltage. All right, so we got 0.5 amps on the condenser fan motor, and the amps are just climbing on the compressor. This is really not good. It's running about double the amps. So we only had about like 74 degrees supply air coming out. You know, this coil never got cold, even though the compressor was running. There's no refrigerant access ports here. Let me see something. I'm gonna turn it off for now. Since there was such a high amperage on that compressor, could have easily went off on thermal overload. There is a thermal overload in that compressor. Let's let this cool off a little bit. I'm gonna pull it out a little, see what's going on. I just heard something click in here. Pull the unit out a little. I mean, this compressor ran for like what, 2 minutes? It's 180 degrees. That's really high. We probably shut off on thermal. We also had like really high amps. I know these kind of systems, they run at like 3.5 to like 3.8 amps as far as the compressor. Okay, so it needs to cool off a little bit. Got 93 degrees in here. Let's turn this back on. I want to see if that condenser fan motor is actually running. Okay, I mean, it's back there. Nothing is spinning. Nothing is spinning. Let's see what's going on. So for the compressor, let's see. This side should always have power. In the relay needs to close, and it goes to that yellow wire. So we are getting voltage to the compressor right now, but it's not starting. So it must be off on thermal overload right now. But that outdoor fan is not spinning. It did pull some amps though, but that doesn't exactly mean that it's running. So this side should always have power. So we got our 120. This is for the condenser fan motor. And then this guy here to ground. You see, we got voltage to that motor right now. Look, we got 0.4 amps, 0.5 amps. This is the outdoor fan. It says out fan. Nothing spinning. This is the indoor fan. Okay, so we got amps on that motor and we have voltage, so it's trying, but I don't see the fan blade spinning. Most likely we got a bad fan motor, condenser fan motor. That could be a reason why the compressor is running on high amps. But I didn't exactly get cooling, like the coil never really got cold. So you know what, I know this thing has a capacitor, so let's turn this off. I'm gonna unplug it. Let's follow the wires. This one. Let's find a capacitor for the outdoor fan. Outdoor fan has, here's a red and orange wire. This is white and red capacitor. It's this capacitor right here. Let's see what the rating is. Looks like 5 microfarads. Let's isolate it and see if we have 5 microfarads. Oh man, that thing is really in there. All right, so this was on the side closer to me. And then the orange wire, that's the 2 wires for the capacitor. Okay, let's set our meter to microfarads. We're gonna read capacitance. Let's check across the 2. .3 microfarads. Right now it's telling me we got a dead capacitor right there, 0.3. That thing is shot. So a good reason to why that thing is not starting is that we have a bad capacitor. Okay, let's start with this. All right, so this is what that capacitor looks like. These are also capacitors. I have a 4 microfarad and a 7.5. So if you go between both here, we got our 4 microfarad on the dot. This 7.5 one, we got 7.2. That one's still decent. So I don't have the exact one, but I think either one of these will work. Let's just see if we can get this started and then come back with the, you know, the exact capacitor. But I think either one of this would probably start this motor. So these solderless connectors are super tiny. You can see it's a big difference from these. So I got some solderless connectors. I'm gonna chop these off, put these on, and give this thing a shot. So this is the 4 microfarad. It's slightly undersized. I want to see if this possibly would start it. And I got the solderless connectors on. I'm just gonna tape around here with some tape so we don't short anything out. Okay, new cap. I got the amp meter on the outdoor fan motor wire, and let's see. Oh, it started. All right, so that's the fan blade. Yes, fans running there. Compressor started. Indoor fan blower is running. Push this thing back in. All right. Let's see, we got 76, 75. Temperatures are coming down, but let's see what we get. And also our compressor. Let's see if our compressor amps get better. Look, we brought it way down. We were going super high on those amps because since the condenser fan motor wasn't running, we weren't able to reject heat. Our head pressure rose, and there's a correlation between pressure and amps as well as temperature. So as the pressure gets higher, so your amps. But you see now we can maintain a decent amperage. And okay, all right, our temperatures are coming down. We got up to 64 now. Let's keep an eye on this. All right, guys. We got a good 55 degrees coming out of the grill. Our compressor is maintaining a good amperage. It's not jumping up so high like before. Our indoor fan motor is running and our outdoor fan motor is running. And yeah, this was awesome. Temperatures are still dropping and it's been staying on. If anybody found this video interesting or helpful, please drop a like, comment, and subscribe. And I'll catch you all next time.